In this section, we're going to talk about triangles. So I'm going to start off by identifying the different types of triangles that we have. All right. So there's not a lot of them. And the first one is going to be what we call an isosceles triangle. Now, what makes an isosceles triangle so special is the fact that we have two angles and two sides that are the same. So to show that, we kind of just put like those little arrows, or I'm sorry, the angles with a little line through it. And then we also tag the sides that are the same as well. So same angles, same sides. All right. The next one is the most famous. I think this is the one that we all know, which is going to be our right triangle. Now, what makes the right triangle so special is it has this right angle right here in the corner. All right. The next is called an equilateral triangle. Now, an equilateral triangle, all the sides, all the angles are all the same. So all sides and angles are the same. And then the fourth triangle, and I'm going to write this off to the right-hand side. We'll write it in red so we can all see it. Is what we call a scalene triangle. And a scalene triangle just means no two sides are equal in length. All right. So it kind of looks like a right angle, but it's like not. It's like a little bit wider. And that's because no two sides are equal length. Now, we do have this really interesting property about triangles, which we can call them similar triangles. All right. So what that means is this. Let's say I have like a little triangle here with the sides 3, 4, 5. Well, a similar triangle would be the same exact type of triangle. All right. It's just they differ by a factor. Meaning, if I were to take the small triangle, 3, 4, 5, and let's say I multiplied everything by 3, well, then this would be 9, 12, 15. So we would call these two similar triangles. And that's because, although they're the same triangle, they are just different in terms of scale. Now, we can use this to our advantage, okay? So let me move this down here a little bit. Obviously, you know what's coming up next, the Pythagorean theorem. So let's say we had this example here. You were standing, and let's say you were 6 feet tall, and the sun is casting a shadow on you that is 15 feet long, okay? Down the road from you is a building, and you have no idea what the height of this building is. Okay, but what we do know, and we can measure it because we can count it out, the shadow is 1,000 feet. Well, here's a scenario where we can use similar triangles to solve this. First, let's create our first triangle, which looks like this. All right, and we know that the sides of the triangle are 6 and 15. This side, we don't even have to know what that is. Now the building, let's form this triangle. All right. And when we look at this, since these two are similar triangles And up above, we said, well, if you have similar triangles, they are equal to each other. What we can form is a proportion. And we learned what a proportion was in the previous chapter. So proportions are fractions equal to fractions. Another way is a ratio equal to a ratio. And here's how we're going to build this. For our human, we know they're 6 feet tall with a 15-foot shadow. A proportion is equal to each other, which means the second fraction has to be the exact same. We don't know how high this building is, but what we do know is the shadow is 1,000 feet. So notice how everything matches. Tall, tall, shadow, shadow. So how do we solve this? 6 over 15 equals x over 1,000. I'm going to move this down a little bit more real quick. There we go. Cross multiply. 6 times 1,000 equals 15x. 6 times 1,000 obviously is 6,000. And finally, all we have to do is just divide both sides by 15. Give us x equals 400. So the building is equal to 400 feet. Now, let's go back to this previous problem. There is a way that we can find what that side is, and it's called the Pythagorean theorem. So the Pythagorean theorem is basically a formula, a squared plus b squared equals c squared. All right, but we have to name everything here. So real quick, the Pythagorean theorem only works on right triangles. All right. The sides of the triangle, A and B, are called legs. The side opposite the right angle is called the hypotenuse. All right, and that's the most important side, is that hypotenuse. Now, if we wanted to figure out what is the length of that side, all we would have to do is take 6 and 15, which are the legs, A and B respectively, and then we could just use the Pythagorean theorem to solve this. So 6 and 15, we substitute them in. 6 to the second power is 36 plus 15 to the second power is 225. Now we add these two numbers together. 36 plus 225 is 261. And finally, we need our calculator to find the square root of 261. So the square root of 261 is 16.2. All right, now, where did I get this square root thing from? I think that's a really good question. When you think about math, all right, if I asked you, like, what is the, like the operation and then its opposite. For example, if I said, okay, I gave you the operation plus. What's the opposite of plus? You would say minus, right? If I said, what's the opposite of division? You would say multiplication. When we take a number and we square it, the opposite is to take the square root of that number. Now, if you have one of the fancy calculators, one of the ones I recommended, I will show you where this button is on your calculator. First thing though is I gotta like do this. There we go. So if you have a calculator that looks like this, you're gonna look for the x squared button first. That's right here. First column, about 4 or 5 buttons down. All right. So if you look above it in blue, and it's going to be kind of hard to see because I know the way that this looks, you're going to see this square root symbol. So I'm going to click on second to get the square root sign, and then just type in 261 and then hit enter. And that's how I got my square root button. All right. So let's do one more example like this. All right. Nothing too crazy. Let's find the missing side. And here we have a right triangle where we have 15, 7. Let's go ahead and let's find A. So remember, Pythagorean theorem, A squared plus B squared equals C squared. Now let's label everything. 7 represents B. 15 represents C. C is always going to be opposite of that right angle. C is always the longest side. So then all we do here is we just make our substitutions. So A squared plus 49 equals 225. Then we're going to subtract 49 from both sides. Give us A squared equals 225 minus 49. It's 176. And then finally, we do that opposite operation. A is going to equal the square root of 176, which gives us 13.3 for the length of A. And that's going to be it for this video.